Welcome to another episode of my home automation / OpenHAB / NodeRED series, and this is going to be another episode on a hardware integration. What I have here is a humidity and temperature sensor which is using Modbus communication, and it is officially called as RS-WS-N01-8. And as you can see, it can measure temperature from -40 to 80 centigrade and relative humidity from 0 to 100%. And it is using RS485 Modbus RTU for communication. The device itself is fairly simple. It has a DIN rail mount, and yeah, it says faulty because this unit is faulty, but my other one is working fine. And it has this really nice, easy to plug connector with 5 terminals, and you are using A and B for the Modbus, and you are using power which can be DC 10 to 13 volts, and the last one is not connected. That's what it says here in Chinese. But before we go on to the Pi, let's hook this up to the laptop. So I have here a USB RS485 converter, so it just plugs into my USB, and then, well, it does a lot of other things besides 485, but basically here I have the D plus and D minus, which then go into like the A and a B sockets or terminals on the humidity sensor, and here in the over these lines I'm feeding 24 volts to this unit. And once you power it up, you see that there is a red LED inside which blinks, and if I remember correctly, it blinks even if it's on standby, or it blinks even if the data is being sent or received. So it's not really a clear indication what's happening with it. I got mine from AliExpress, and if you go on AliExpress, you can't search by this type, which is the RS-WS-N01-8, but you just have to search by Modbus temperature sensors, and you would immediately see that it's coming up in quite a few listings, and with quite a bit different pricing as well. Okay, probably not so much. I'm not sure which one I got mine originally, but I remember paying around $20 for it per piece with free shipping. So again, you might say that, I can do temperature sensors cheaper than 20 degrees, but you have to remember that it is temperature and humidity, and it has the communication protocol as well, which comes in handy if you are not right next to your Raspberry Pi. So you need some sort of data line to get the data in from your sensor to Raspberry Pi. And just keep in mind that RS485 is a good industry standard. So, and it handles a couple of 100 meters per segment easily. And you can obviously daisy chain multiple units onto the same line. And it only takes 2 wires. If you look at the listing, you wouldn't find a lot of information. You see here it says RKVS, and it pretty much tells you the same information and some really basic diagrams, how you need to connect it and physical dimensions. I'm using this Modbus scanner program just to read the values and also make some configuration changes to this unit. So first, I've set up a really simple task of reading the registered out of the unit. So first of all, I need to set up the connection. So I'm using COM2 for this blue device, the USB serial converter, and which is not really mentioned clearly in most of the documentation, that the basic settings for this unit is 48,000 baud, 8 data bits, 1 stop bits, and no parity. So you need to set your serial connection to that. The next one is the default device ID is 1, which is quite usual for all these devices. And then next is you need to use function 3 to read the holding registers with offset 1 and length 2. So we read the first 2 registers. And if you do that, you will see that we are getting two values out of the unit. The first one is 376, which is the relative humidity with one decimal place. So that's 37.6%, and the second value 240 is a 24.0 centigrade. Well, the temperature is 24 degrees centigrade. And if I keep refreshing that, then you can see that this value changes. And if I just blow on the unit, then you can see that the humidity and should rise slowly, and also the temperature, and then it falls back nicely. So I think the chip inside is quite a good one, so it's quite responsive to humidity and temperature changes as well. And what you expect in most of these units is you can use the same software to make these changes to the unit settings, like the speed and the device ID, but actually it's something different. To change the unit setting, you need a special tool to do that. And I managed to get this from the supplier eventually after a couple of email exchanges, and they sent me a lot of different documentation and software and some debugging applications as well. But what I ended up using is this one, which is the it's called 485 parameter configuration tool.exe. And then when you execute, then you get this really nice information message, and then when you click on that, you get this really the other really informative screen as well. So obviously this is all Chinese, and because I don't have the Chinese character set, it's all coming up with question marks. But using this software is fairly easy. So you need to select your COM port, and so I know that my device is on COM2, so you click on COM, and you see some stuff is coming through, and basically you can make out that it's saying number 1, which is the station ID, and 4800, which is the baud, and these two values are coming up here as well. So and there are some other things here which, well, actually there is a documentation for that, how to use it. So I've also got this text file, like you can get the temperature value and the humidity value. So all this information is coming back, and I'm guessing this software is also used for some other products, because like voltage illumination doesn't make sense for some of the other things. It doesn't explain what is the humidity limit and the temperature limit, but again, I'm guessing there could be another product where all these values make sense. But again, let's not bother about that, because all we need about is these two upper rows here, which is the device address. So I'm going to set my device to 50, and you click on set, and you get this message back, which doesn't tell you much. And I'm going to set the speed to 9600, and if I believe 9600 is the maximum speed for this unit, so I'm going to do a set. And if I actually do inquire, well, I don't see any changes, but I should be getting the same values back from my device. So let's hope that all these changes were successful. So if I'm coming back here and I'm changing the speed, and I'm changing the station ID, and I do poll, I get the information back. So as you can see, we managed to change the speed and the station ID on this unit, and actually you can see here in the response, like connected, 9600, and we sent the message, and the first character is the station ID, so we sent 32, and we were getting the response back. So this is how you change the settings on your temperature and humidity sensor. To read the temperature and the humidity sensors in OpenHAB, we need to do a few things. So first is to add Modbus binding to the OpenHAB installation. You can read this article about the details, but it's basically just copying the YAR file into your OpenHAB installation. So then you can start using the binding. The next, let's go into the configuration, and first we have to go into the OpenHAB config, because the basic Modbus configuration needs to be done there. And you need to add these lines to your OpenHAB configuration. So the first is just a command line, just to remind myself what I'm doing here. So next is you need these lines, these, what is it, 6 lines. So the first one is the Modbus serial, the name of the unit or the sensor or the device is going to be RS-WS-Temp. So dot connection is I'm using the USB, the same blue USB device to convert my USB to RS485. So my device is the dev TTY USB 0, and the connection settings is 96,000 baud, 8 data bits, no stop bit, and 1 parity or whatever it is. So it's the same settings what we have seen in the previous screen after we changed the baud settings on the unit, and we are using RTU. So the next one is the type. It is using the holding registers. The value type is N16 because it's storing both of the values in 2 integers. So it's like a high high value and low value. And we are going to read 2 registers starting from 0. And the ID is 50. You have to remember that this start is always like the first register is 0. And the ID is 50 because we again changed that. So that's all about the config. So the next one is the item configuration. For the item configuration, we are adding, or I have added 4 items. The reason being because the information which is coming back from the device is in it's an integer value with the the last digit is the decimal place, so we need to convert it. But within the item configuration there is no transformation available, so we need a rule to transfer this information. So first of all, I'm going to read the values into a temp variable. So I have created an item RS-WS humidity temp and RS-WS temperature temp, actually the icon is not really important, but the thing is in the item config I'm using Modbus equals RS-WS temp 0 and RS-WS temp 1 because the first register is the humidity, the second one is the temperature, and again this value corresponds to this value, sorry, this one in the config. So I'm reading the 2 values, and I've created 2 other variables or items that actually I'm going to use to display the values. So the humidity is now float with 1 point decimal in percent, and the temperature is again float 1 point decimal in centigrades. And on the sitemap is really simple because I'm just adding the 2 values. Again, remember, it's not the temp values. So the thing is, the magic happens in a rule. Sorry, this one. So I created a new rule file, rs_temp rule, and in here I've done this really small script. Basically, it's 2 rules, and one fires when the temperature, the RS-WS temperature temp receives an update, and the second one is when the RS-WS humidity temp receives an update. And basically all I'm doing here is reading the value, dividing it by 10 and passing that over to the actual value. So and to do that I'm using this float, parse float, the temp value dot state to string and divide by 10. So it's not really complicated, just a lot of typecasting going around. And I had to well, it wasn't easy to put this code together, and I don't think this library is required anymore, but anyway, this works now, so you need to add that, and that's pretty much it. And once you have it up and running, you can see that the temperature and the humidity sensor is showing up correctly. And just to make sure that it's live, I was just blowing on the sensor, and you can see that the humidity is rising. And by the way, if you want to see the output as well, you will be able to see the messages going back and forth. So if I just pause it, you can see here is send 3203 blah blah blah, and then received, and then the execute the rule which converts the humidity value and the temperature value gets executed. So it is working quite nicely. By the way, one thing I forgot to mention, in the config file you also add this. I think the default is 500, so Modbus poll equals the milliseconds. Is it milliseconds? Yes, it's milliseconds. How frequently the OpenHAB updates the Modbus, in this case how frequent it is getting the data from the device. So it's like it gets an update every half a second, so you can lower that if you need to. But that's all there is to it to get the values and convert it nicely into a readable format in OpenHAB. To use Modbus serial on NodeRED, you again come to NodeRED.org and you click on flows, and you type Modbus to look for Modbus nodes. And there are a few ones which are only for TCP, but you need this one, the NodeRED contrib serial Modbus, which implements the NodeBus protocol over serial port. And you need this command to install this library. If you have done everything correctly, you should see in the under NodeRED in the filters, you see a new group which is called Modbus, and there is going to be a Modbus serial. There's going to be an in and out node, and obviously we are going to use the in node because we are getting data from the Nodebus device. So you drag this onto your screen, and then you set up your device. Again, I'm using a USB device, and the baud rate is 9600 and 8 data bits, no parity, and 1 stop bit. So it's the usual, same as before. And what you set up here is you set up the slaves. And if you would have multiple of these temperature sensors, then you can just list the slave IDs or the device IDs separated by comma. I only have one, which is called the ID is 50, so station ID is 50. It has the type of holding registers, and again, I'm starting from count 0, I'm reading 2, and the poll period is 1. In this case, this is seconds. And actually, what I also want to do here is put another payload here. So sorry, another debug window, not this one. So we can see what is coming out of the unit. And so now this debug window is active, and you can see the data which is coming back from the from this Modbus node, and you can see that this is like a raw data, so that needs to be converted into a format that we can read. So I put this function block here, which is fairly simple. So it reads the payload into a local variable, which is just going to be like a buffer variable, and I'm using this function to convert the temperature. It's basically you know, the first data is the low register, and then the high sorry, it's the other way around. So it's basically converting the low registers and high registers into a fixed integer value and dividing it by 10, because we are getting the data in with 0.1 decimal place accuracy. And then I just create a small JavaScript object, so I can just convert this data into a JavaScript object. So I'm using .temp and .humid to store the temperature and the humidity. So if let me stop this debug, sorry, stop, and then I clear, and I start this other debug, which is actually showing the data which is going out from the function book. You can see that again, we are seeing the temperature and the humidity in an object format. And I have connected that to two UI nodes. So the first one is showing the msg.payload.temp, and the other one is the msg.payload.humid. And if I switch over to the UI, Now we have a group. I've created a group which is the RS-WS-N01-8, and then it is showing the temperature and the humidity values, and you can believe me that if it changes, the screen will update as well. That would be all about using this Modbus temperature and humidity sensor. You find the links to programs and examples in the video description. Thanks for watching, and see you in the next video.